Good morning. I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today I am going to discuss about ammeter, types of ammeters, voltmeter and different types of voltmeters. Ammeter is mainly used to measure the current. In this, with the help of PMMC meter, we can measure the current by connecting a resistance in parallel with the meter movement. When we observe the construction of DC ammeter, a resistance is connected in parallel with the PMMC meter. So, this will be acting as a DC ammeter. The DC ammeter is mainly used to measure the current. The single resistance is used whenever we need to measure a single current. For example, if you want to measure different currents of different ranges, we go for multi-range ammeter. In this multi-range ammeter, we have different resistances which are connected in parallel with the meter movement. In multi-range ammeter, we have 4 resistances in this connection: R1, R2, R3 and R4. So, the 4 resistances are connected in parallel with the PMMC meter. At the same time, each resistance is in parallel with the next resistance. That is the advantage of multi-range ammeter. In this, depends upon our requirement, we can connect any of these resistances in parallel with the meter movement. Only one resistance can be connected at any time. To connect any one of the resistances in parallel with the meter, we have a switch S. The switch S can be connected either to the resistance R4, R3, R2 or R1. Now this switch S is called as make before break switch. That is, if you want to connect it to the resistance R4, initially that is connected to the resistance R2 means initially the switch makes the connections towards R4 and then it removes the connection across R2 so that we get connection establishment between the resistance and the switch. So there is no loading effect. Like that, make before break switch means before removing the connection of older one, we have to connect it to the new resistance so that the circuit will be connected to the new resistance and hence any loading problems that is present that can be overcome. So this is called as multi-range ammeter. In this multi-range ammeter, different resistances are used with different ranges. Suppose for example, the R1 having the resistance 1 kilo ohm, R2 we are using 100 kilo ohms and R3 is in terms of ohms, 100 ohms like that. So if we choose different resistances have different values, we get different ranges of currents. This is about multi-range ammeter. This is mainly used to measure currents of different ranges. Next, return shunt or universal shunt. This is also one type of ammeter. In this return shunt or universal shunt ammeter, the resistances are connected in series with each other, but each and every resistance is connected in parallel with the meter movement. If we observe the construction of a return shunt or universal shunt, we have in this circuit we have 3 resistances. Those are represented with RA, RB and RC, and each resistance is connected in parallel with the meter movement, but individually each resistance is in series. This return shunt or universal shunt is mainly used to overcome the problems present in multi-range ammeter. So, at any instant, we can connect any one resistance to the meter. For example, in this return shunt or universal shunt, if you observe that The switch S is connected to resistance RA. When the switch is connected to the resistance RA, then the resistance RA is in parallel with the series combination of RB, RC and meter. Similarly, if the switch S is connected to through the point 2 to the resistance RB, then we have parallel combination of RA, RB which are in parallel with the series combination of RC and meter resistance. In the third case, if the switch is connected through the point 3 to the resistance RC, then RA, RB and RC are in parallel with the meter movement. So, this Aeronautical shunt or universal shunt can overcome the problems that are occurred in multi-range ammeter. With the help of Aeronautical shunt or universal shunt also we can measure different currents of different ranges. Once again observe the circuit. The circuit consists of three resistances RA, RB and RC, and each resistance is in parallel with the meter resistance PMMC meter. At the same time, individual resistances that are connected either in series or in parallel based upon our connections. Along with these three resistances, we have one PMMC meter that is connected in parallel to the resistances. So, to choose which resistance we need to connect, we have a switch S, and the switch S having 3 points 1, 2, 3. Now, coming to the operation of universal shunt or Aeronautical shunt, it has three different cases. In the first case, the resistance RA is connected with the help of switch 1. Then the resistance RA is in parallel with the series combination of RB, RC and RL. Similarly, when we connect in case 2, if you observe the second case, then the resistance in case 2, the resistance RB is connected through the switch 2. Then RA and RB, both the resistances RA and RB are in parallel with the series combination of RC and R. Whenever we connect resistance RB through the switch 2. Similarly, coming to the case 3, in third case, we are connecting resistance R3, resistance RC. Then RA, RB, RC are in parallel with the meter movement. So, depends upon our requirement, we can choose either resistance RA, RB or RC. Then corresponding to that, we will get series and parallel combinations. Finally, we can measure different currents. This is called as Aeronautical shunt or universal shunt. Finally, we have three different types of ammeters. One is simple ammeter and second one is multi-range ammeter. And third one is Aeronautical shunt or universal shunt. So, we have three different types of ammeters. Simple ammeter. With this, we can measure a current with particular range. If you want to measure different currents of different ranges, then we go for multi-range ammeter. In multi-range ammeter, sometimes there exists a problem of loading effect due to all the resistances are parallel to the meter. At the same time, each and every resistance is in parallel with the another resistance. To avoid the problems occurred while we are using multi-range ammeter, we go for a return shunt or universal shunt. In this return and universal shunt also, we can measure different currents of different ranges without any loading effect. This is about ammeters. Next, coming to the voltmeter. So, this is the construction of voltmeter. Voltmeter is generally used to measure the voltages. We have different types of voltmeters of different ranges. Normally, we have AC voltmeters and DC voltmeters. AC voltmeters can measure the voltage with the help of needle. In DC voltmeter, we can directly measure the readings by using PMMC meter. This is the construction of DC voltmeter. In this, a resistance is connected in series with the meter movement. Then this is called as DC voltmeter. As we observe the difference between ammeter and voltmeter, in ammeter, the resistance is connected in parallel with the meter movement or PMMC meter. This is PMMC meter. In voltmeter, the resistance is connected in series with the PMMC meter. So, this series resistance RS is also called as multiplier resistance. And the total voltage present across this voltmeter is V, and the resistance present across PMMC meter is denoted with RM, and the current present in the meter is IM. The total current present in the circuit is represented with I. Similar to the ammeters, voltmeters are used to measure the voltages. If you want to measure single voltage, we go for simple voltmeter. If you want to measure different voltages of different ranges, then we go for multi-range voltmeter. This is the construction of multi-range voltmeter. Each resistance can be connected with the help of switch. So, with this, we can connect to either first resistance R1, R2, R3. In multi-range voltmeter, we have different resistances and each resistance is connected in series with the meter movement. At the same time, each and individual resistances are connected in parallel in series with the meter, and each resistance is also connected in series with the another resistance. So, in this, similar to multi-range ammeter, in multi-range voltmeter also, we can connect any one resistance with the help of switch S. Here also the switch is called as make before break switch. So, initially the switch is connected to resistance R1. If you want to change the connection from resistance R1 to R2, first we have to make the connections from switch S to R2. Then remove the connections present across R1 so that the circuit is connected to resistance R2. With the help of resistance R2, we can measure the output of this. This is DC voltmeter. So, in multi-range voltmeter, we can connect different resistances of different ranges. Depends upon our requirement, we can choose a particular resistance for the measurement of voltage. This is one way to construct multi-range voltmeter. The another way to measure multi-range voltmeter, construct multi-range voltmeter means this is resistance R1, R2, R3. RM and I. So this is also one way to construct multi-range voltmeter. In this multi-range voltmeter, we have different resistances from R1, R2, R3 and so on, RL. So that we can connect any one resistance of our choice in series with the meter movement so that it will be acting as an voltmeter. In this particular connection, each resistance is in series with the meter, whereas individually all the resistances are connected in parallel with each other. The resistance R1 is connected in parallel with the resistance R2, whereas it is also parallel with the resistance R3. But individually, the resistances are connected in series with the PMMC meter. So, in this multi-range voltmeter also we have a switch S. With the help of switch S, we can connect to either resistance R1 or to either resistance R2 or R3. Based upon our requirement, we can choose any one resistance and the remaining two resistances are removed so that a particular resistance is connected in series with the meter movement, and finally we can measure the voltage. This is another type of measuring the voltage using multi-range voltmeter. Finally, we have different types of voltages, different types of voltmeters which are helpful to measure the voltage by using different circuit. So, along with the ammeter, the voltmeter is used to measure the voltage. This is the circuit which represents a simple voltmeter to measure the voltage. In this voltmeter, the resistance is connected in series with the meter movement, whereas in ammeter, the resistance is connected in shunt with the meter movement. So, with the help of simple voltmeter, we can measure the voltages of a particular reading. If you want to measure different voltages across different readings, instead of using simple voltmeter, we go for multi-range voltmeter. In this multi-range voltmeter, we can measure different voltages of different ranges. For that purpose, instead of using single resistance, we need to use n number of resistances, and each resistance is connected to a particular voltmeter based upon the switch S. With the help of switch S, we can connect any one resistance in series with the meter movement. At that time, remaining resistances are removed from the connection so that we can choose any one resistance and which is connected in series with the meter movement, and finally we can measure the voltage. So, if in multi-range voltmeters, if you use n number of resistances also, each resistance is connected in series with the meter movement, and individually all the resistances may be connected in parallel or in series, but individual resistance should be connected in series with the meter movement. This is about DC voltmeters. Today we have discussed about ammeter and voltmeter. This DC ammeter and DC voltmeter, if we observe the construction, when we connect a resistance in parallel with the PMMC meter, then this construction is called as DC ammeter, which is helpful to measure the current. Similarly, if you have multi-range ammeter, with this we can measure different current ranges with the help of different resistances. Here we have different resistances R1, R2, R3, R4, and we can connect up to RN. In these n resistances, each resistance can be selected with the help of a switch S. By using the switch S, we can connect any one resistance that is in parallel with the meter movement, and finally we can measure different currents. Next, we have a return shunt or universal shunt. With this, whatever the problems that are observed in multi-range ammeter can be overcome. The main problem present in the multi-range ammeter is all the resistances are always connected in parallel with the meter movement. Due to this, sometimes there may be existence of loading effect. To overcome that loading effect, in this return shunt or universal shunt, all the resistances are connected either in series or parallel based upon the requirement or choosing a particular resistance RA, RB and RC. Next one is voltmeter. Similar to the ammeter, if a particular resistance is connected in series with the meter movement, then that is called as DC voltmeter, which is helpful to measure the voltages. Similar to the ammeters, in voltmeters also we have multi-range voltmeter. That multi-range voltmeter is used to measure voltages of different ranges. In this, the construction the construction of multi-range voltmeter, if we observe, all the resistances are connected in series with the meter movement, whereas the individual resistances may be connected in series or in parallel. So, along with this ammeter and voltmeter, we have another type of meter that is called as ohmmeter. That ohmmeter is mainly used to measure the resistances. We have two types of ohmmeters, series ohmmeter and shunt ohmmeter. That series and shunt ohmmeters are helpful to measure the resistances. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.